Alright, welcome back to the new video on graph theory. Since I was not able to take class, so I have made a small video. Go through this, and in the end of this video there is an assignment. Do that assignment and submit. That's your assignment, okay? So once you've studied the types of graph, for the types of graph I have also uploaded one PDF in Google Classroom. You can go through that for your revision. Now once graph is made, once the graph is made, you have something called a graph that is made, isn't it? Whether it is a simple graph or regular graph or whatever kind of graph it is, once the graph is made, I am supposed to traverse the graph, because I am supposed to traverse the graph. I am supposed to traverse the graph in the sense I am supposed to walk the graph. That means from A to, I wanted to go to from A to E, from A to B, from A to C. How do I go, and what are the types through which I can go? So on that we have a class here. Now when I traverse, when I walk through the graph, we call in graph theory it's a walk. It's a defined as work. Now walk is a sequence of vertices and edges. Either you can write edge, if edge names are given you can write edge, or if only the vertices are given you can write vertices as a sequence of walk. For example, if you want to go from A to E, what are the possible walks? Possible walks could be from A to E, from A to C, from C to E is one walk, from A to B, from B to C and C to E is another walk, from A to B, B to D and D to E is another possible walk, isn't it? And one more walk is there. We can have one more walk. So this walk is from A to C, C to B, B to D and D to E. Yeah, so here itself I have made four different ways through which I can reach E. Now walks, just understand that walk is the length, or walk is a sequence of vertices through which you traverse. You traverse in the sense you walk from one place, one node to another, one vertices to another vertices. Now here I have given a small example here. Look at this example. A, B, C, E, D. A, B, C, E, D is one walk of length 4. Because, why it is 4? Because the total number of edges covered is length, right? Total number of edges covered is length. Because we later on we'll have to add this lengths. Because A to B is one length. And maybe from Namchi to Dorthang is one length. Dorthang to Malli is another length. Malli to Rampu is another length. And Rampu to Gentok is another length. So total, yeah, the walk from here to D, from Namchi to Gentok, if I want to reach, then I'll have to walk like this. Or I can straight go to A to from Namchi to Pakyong Airport to Gentok. Straight you can go. Something like that. So length are the number of edges that is covered. Alright, you understand that. Then we have different types of walk. We're having different types of walk on it. We have different types of walk. Now one is open walk. What is open walk? Open walk in the sense, open walk is the walk. It's a walk. but then it does not reach the destination as a source. That means this particular just hang on, this particular is close. All right, because I am reaching at the same place, closing. But if I don't want to close, I don't want to return, then this, if I want to go here till B, it is open walk. It is open, isn't it? It's an open walk. Now if I go to C again, it becomes a close walk. This becomes a close walk. Alright, so open and close you have to understand. Open walk and close walk. I have given a few examples also here. You can see these examples. Then there is a note saying that if length of the walk is 0, then it's a trivial walk. Okay, and you must understand that both vertices and edges can repeat in a walk. Whether it is open walk or close walk, you can repeat the edges and the vertices. You can repeat it. Now comes the different types of open walk and different types of close walk. That's what we call it as path. We call it as path. Now what are path? Path is an open walk. Path is an open walk. That means it's an open walk. Alright, it's an open walk where neither vertices nor edges are repeated. मतलब सेम रूटमा म हिँड्नु भएन, सेम जग्गामा म पुग्नु भएन. Neither edges nor vertices are repeated. So I have given you example here. A, B, C, E, D is an open walk. A, B, C, E, D. This is an open walk, isn't it? It's an open walk, but it is a path. Why it is path? Because I have not repeated any vertices and I have not repeated any edges. No repeats are allowed. Similarly, cycle is another walk. Cycle is another walk wherein you understand cycle भनेको जहाँबाट start गरेको थियो. From there, I'm reaching at the same place. So it's a close walk, isn't it? Obviously it's a close walk. Now, for the same diagram, for the same graph, if you can see this, walk A, B, D, E, C, A. A, B, D, E, C, A is a cycle. It's a cycle because it's a close walk. So, where no vertices and no edges are repeated. Alright, understand that. And one more type of walk is trail. We call it as trail. Now, trail is an open walk where vertices may repeat. Vertices may repeat, but edges are not allowed to repeat. You have to understand this. You have to remember this. Better than understanding, you have to remember this. Now, here I have given you example of A, B, C, E, D. What happened here? A, B, C, E, D, and B, because it's a but edges are not allowed to repeat. Edges are not repeat. Okay, here I have a mistake here. I made a mistake here. You can come only to till D. Okay, you can come only till D. So you correct this part lah. Correct this part. So A, B, C, E, D. A, B, C, E, D. A, B, C, E, D is it's an open walk, but it's an open walk where vertices may be repeated. Vertices may be repeated, but edges cannot be repeated. अब यहाँ म B मा, if I go to B, then it becomes closed. That's why I erase this. Now let's say another one. A, B, A, B, D, E, C, E. This is one of the open walk, which is a trail. Which is a trail. Now next what we have is circuit. Now it is just opposite of a trail. Circuit is opposite of a trail, wherein vertices may be repeated, yes, but then edges are not allowed to repeat, yes, but it has to be a close walk. Matlab from where I have started, I have to reach there. A, B, C, A. A, B, C, A. This is a circuit. I am starting from A, B, D, A, B, D, E, C, A is a close. A, B, D, A, B, D, A, B, D, C. You cannot go to C. There is no path from here to C. So there is also mistake here. But then I can go to E, C, and I have left out E here. Yeah, E lekhnula. You write down E here. Now this becomes a circuit again. Alright, understand this. Now there is a very important point here. You must remember this point. Every path is a trail, but every trail need not be a path. Isn't it? Every cycle is a circuit, but every circuit need not be a cycle. And for directed graph, these are all undirected graph, isn't it? If we have directed graph like this, if I have a directed graph, isn't it? Some directions are given from here to here, then we just write directed. We just write a directed term in front of the front of all above, like walks, path, trail, circuit, whatever we write, we write directed in front of the terms above. Now there is a small chart I have given. Now you can look at the chart and try and figure out what is it. If it is a walk, then if no edges or no vertices are repeated, it's a path. If no edges are repeated, vertices may be repeated, is a trail, isn't it? If it is a closed Babini, it's a circuit. If path is a closed, then it is a cycle. And every path is a trail and every cycle is a circuit. Okay, you remember this part. Now I have done few problems here in this graphs. Look at the problems. I have given you the solution also. Do the problem and correct. Check the solutions. Okay, check the solutions. Do the problem. Check the solutions, and then there is a final. There is one assignment I have given you. The problem number 3 is your assignment. Okay, and now for this graph, for this particular graph, observe this sequences of walks I have given and write down. Okay, and write down what are they. They are trail, they could be a circuit, there could be a simple walk, they could be an open walk. Write down all these things. Okay, do that part. We will have a class. We will have a discussion if you have any problem in the class. Okay, when we have class. Okay, bye.